This topic is relations and functions. So if you will look at your notes at the top, it says define and identify relations and functions. A relation is any set of ordered pairs, so it's just a set of ordered pairs, and a function is a relation in which for every value of the first component of the ordered pair, there is exactly one value of the second component. Or in other words, for every x, there is only one y. Now there's a couple ways you can show relations and functions, and I have those listed here. First, you can show them as a set of ordered pairs, as in the definition. So I have the set F, and it's listed as the set of ordered pairs 1, 2, -2, -4, and 3, 6. You can show them, secondly, as a correspondence or a mapping. This one is very, very helpful. For me, this is the one that makes the definition most visual. So I'm going to take this set up here and I'm going to do a mapping of that set. So you make two rings. Your x's go in the first ring, your y's go in the second ring, and in this case my x's are 1, -2, and 3. My y's are 2, -4, and 6. And then the mapping or the correspondence occurs when you connect them. So 1 maps to 2, -2 maps to -4, and 3 maps to 6. And you will see shortly why this is such a valuable method for determining if a relation is a function. The third way you can show relations and functions is as a table, and you're already familiar with that. I can do an XY table with the same points from my set or from my mapping. I have the point 1, 2, -2, -4, and 3, 6. It's similar to the mapping where it splits the x's and the y's, but it's in a table. We can do it as a graph. I have the point 1, 2, -2, -1, 2, 3, 4, and the point 3, 1, 2, 3, 4, 5, 6. And in this particular case, when I connect my plotted points, I end up with a straight line. That doesn't always happen, by the way. You can also show it as an equation. The relationship between the x and the y is that if I take any x, so let's say 1, and I multiply it by 2, I end up with the y. Any x times 2 is the y. Any x times 2 is the y. So that equation is y equals 2 times x. So those are the 5 ways you can show a relation or a function. Now let's look at how you determine whether a relation is a function, because not every relation is a function. So let's start with 1a. I have the set F defined by that list of ordered pairs, and the best way to see if this relation is also a function is to map it. So I'm going to put my x's here, 1, -2, and 3. My y's go here, 2, 4, and -1. Now I actually do the correspondence. 1 corresponds to 2, -2 maps to 4, 3 goes to -1. Each of my x's, it's all about the x's here, each of the x's, 1, -2, and 3, only goes one place. Therefore, yes, this is a function. Let's look at the second set, G. I'm going to do a mapping of my x's and my y's. So in this case, my x's are -2, -1, 0, 1, and 2. So -2, -1, 0, 1, and 2. My y's are -1, 0, 1, and 2. I have a second 2, but you don't repeat that when you write it down. So -1, 0, 1, and 2. And now let's do the mapping. -2 maps to -1. -1 maps to 0. 0 maps to 1. 1 corresponds to 2, and 2 also corresponds to 2. Now listen very carefully to the question. Does every x only go to 1y? Well, let's see. -2 only goes to -1. -1 only goes to 0. 0 only goes to 1, 1 only goes to 2, and 2 only goes to 2. It doesn't matter that 1 and 2 both go to the same place. They only each go to one place. So yes, this also is a function. So it doesn't matter if one of the y's receives more than one x. That's okay. Let's look at the set H. Here are my x's. Here are my y's. My x's are -4, -2, and then -2 is repeated, but I don't show it twice. And then I have 1. 1 is repeated, but I don't show it twice. And 0. -4 maps to 1. -2 maps to 1. We know that that's okay, but now when -2 also maps to 0, that is not okay, because you can see that the 2 is going two different places. The -2, excuse me, is going two different places. So no, this one is not a function because the -2 goes to two different places. Now let's talk a little bit more about functions and relations, and we're going to talk about the domain and the range. Just new definitions for old words. In a relation, the set of all the x values is called the domain, and the set of all the y values is called the range. So we're going to do the same thing we just did, but we're going to list the domain and range here. So it says give the domain and range of each relation and tell whether it is a function. And I'm given a set F. So we're going to use our mapping simply because, again, I think it's the easiest way to see if a set is a function, a relation. So my x's are 2, 3, 4, and 5. They go to 5, 7, 9, and 11 as my y's. So 2 maps to 5, 3 corresponds to 7, 4 relates to 9, and 5 goes with 11. Is it a function? Yes, it is a function because every x only goes to one y. The domain now I'm going to show as a set, and I'm just going to list these x values again. So this is the same thing as the domain. So we have 2, 3, 4, and 5, and the range is 5, 7, 9, and 11. So it's just separating out the x's and the y's and showing them as a set. Nothing too mysterious about that. Let's look at set G and go through the same process. Our x's or our domain and our y's or our range. My x's are 1, 2, 3, and then 2's repeated, and 5. My y's are 10, 15, 19, and then 19's repeated, and 27. Let's do our mapping. 1 maps to 10, 2 maps to 15, 3 maps to 19. Now it says 2 maps to 19. I really don't need to finish. I don't need to go any further with the 5 going to the 27 because as soon as that 2 is going two places, it is not a function. So no, it is not a function. The domain is 1, 2, 3, and 5. Again, you don't repeat if one of those x's is repeated. And the range is 10, 15, 19, and 27. But it's still not a function. Now, if you're given a graph instead of a mapping or a set, you can very, very easily tell if you have a function by using what's called the vertical line test. And all that means is on your graph, you draw a vertical line down through that graph. And if it only crosses the graph in one point, it is a function. Well, in this case, you can see it crosses 1, 2, 3, 4. So it is definitely not a function. When I look at this one that looks like a W, if I draw a vertical line here or here, it doesn't matter where I put it, it still only crosses, each vertical line only crosses in one place. So yes, that is a function. So let's look at the bottom 3 and we're going to determine if they are functions or not. That one definitely is a function. It only crosses in one place, so that is a yes. And by the way, other than a vertical line, all straight lines would be functions. Let's look at this parabola. Drop a vertical line. For the vertical line test, it only crosses in one place. Yes, that is a function. This last one, when I draw a vertical line, it crosses in two places. So no, that is not a function.